Now, when it comes to indexing, Postgres is much more advanced compared to the other databases in terms of types, because you have these custom types, and these custom types give you a lot of power also when it comes to indexing. Postgres supports, unlike for instance like it was the case for SQL Server, it gives you this possibility of using an inverted index. These inverted indexes are exactly what happens when you're using Lucene, Elasticsearch, or Solr. So basically it allows you to tokenize it. You take a document, tokenize it based on some specific rules. Here you can use the JSON specific rules, and then you build a representation. In the index you build a representation that's tailored to JSONB in our case. So what exactly you can do? You can build one index. A single index can serve several operators. Like for instance, this type of index here is going to work for check, like for instance existing, like it was the case with JSON exist previously, or for instance you can check whether some elements are contained or not, multiple of them, or even check whether some key value pairs are included in your JSON objects. Like for instance, you want to check not only that the attribute itself exists, but also the associated value is the one that it matches the one that I provided as well. So how can you do that? If properties is the name of the JSONB column storing my JSON objects, I'm using a gene index, and then as you can see, when I'm executing a query that tries to see whether I have this attribute or not, so I'm using this question mark sign, which tries to see whether there is any attribute inside this properties JSONB object called publisher, and when I'm looking there, I can see that it used a bitmap index scan on this gene index that I had. So it actually worked. And what's interesting about these gene indexes in Postgres is by default it uses these JSONB operators. That's like a class of operators that you can use. But if most of the time you're using only these inclusion operators, which check the existence of key value pairs, and then you can use these JSONB path operators. This is a new class of operators, which the difference between this one and this one, the default one, is that this one only works with these operators, but it stores the index in a much more compact fashion. And because it's much more compact, it's going to take less space, and it's also optimized for this type of operators. So if you want more performance out of these operators, you can build your genes and only for these specific types of operators. The difference is that if you do that, you cannot use the previous ones, like the question mark. It will not going to work for this type of operators, but this one is going to be faster. So you have this option if you want. However, that only works for top level attributes. If you want to do if your queries need to go inside the structure, so they have to go inside arrays, they have to go inside nested objects. So if you want to go inside the structure, you will have to use this arrow attribute, and in consequence, you will have to create your gene index based on what you are to reference there. So for instance, if I'm operating against this reviews array and I want to index the path to the reviews array, I will have to do it like that. So I have to build my gene index either for that reviews array or for the nested object, or for a nested object that's identified by that path expression. So in that case, what I wanted to optimize here, I wanted to check whether there is an element in my reviews array that has a rating of 5. So in order to speed up this type of query, I cannot use the previous query. I will have to use a query like that. So that's as you can see, you have options, but they are not as flexible as you had a case for your relational model. Yes, you can index them, but it's not. You are much more limited compared to the relational model. So knowing that, it will be easier for you to decide whether a JSON model fits better than the relational model for specific use cases that you have.
If you like this video, you are going to love my high-performance SQL video course.
For more details, go to my blog vladmihalcha.com and check out the courses page. If you're struggling with data access performance issues, this video course will teach you how to get the most out of your relational database. You have unlimited access to the course material and 14 days money-back guarantee. If you are curious what other people think about the video course lessons, then you should definitely read the testimonials I got from my students. Thank you for watching this video and enjoy running your data access layer at high speeds.